Good morning, students. Today we will be discussing whatever we had discussed earlier, and we will go towards whatever we have to learn today. Now, first of all, the linear momentum is equal to mv, and the SI unit is kilogram meter per second inverse or kilogram meter per second. Then change in linear momentum delta p equal to m into v minus u, where v is the final velocity of the body, u is the initial velocity of the body, and m is the mass of the body. And the unit is kilogram meter per second inverse. Also, we can take another unit. Just look, delta p equal to m into v minus u divided by t into t. So t cancelled, we will be getting m into v minus u again. Now, if you are considering this part, m into v minus u by t, what is that? That is nothing but ma. The unit of ma, unit of force. What is the unit of force? Newton. So Newton second. So we can also call the unit of change in momentum is Newton second or kilogram meter per second inverse. Both are unit of change in momentum in SI unit. Now again, F is equal to ma, that is our second law. The unit of force is nothing but Newton. It can be also written as Newton. Now if you are looking at it in terms of base quantity or base unit, or it is also called absolute unit, it is kilogram meter per second square. Now that's what we have already learned. Okay, so we had a quick look on whatever we have already learned. Now we are going towards whatever we have to learn. Now, if you are the first one, definition of 1 Newton force. How to define 1 Newton force, or what is the magnitude of 1 Newton force, or what is 1 Newton force? Now imagine we are having a body of mass 1 kilogram, okay, and it is being accelerated with a magnitude 1 meter per second square. So the acceleration is 1 meter per second square, and the mass of the body is 1 kilogram. Then what is the force required? 1 into 1. 1 kilogram into 1 meter per second square, that is 1 into 1 is nothing but 1. So 1 Newton force. So 1 Newton force is that force which needed to accelerate a body 1 meter per second square, which needed to accelerate a body 1 meter per second square of mass 1 kilogram, or we can also call 1 Newton force is the force which is required to accelerate a body of mass 1 kilogram with 1 meter per second square. If a body is being accelerated 1 meter per second square having mass 1 kilogram, then the force required is called 1 Newton force. Now if you are looking at the CGS unit of force, that is dyne, D-Y-N-E, dyne. So 1 dyne is equal to, again we can relate it since it is in CGS. C stands for centimeter, G stands for gram, S stands for second. Then gram, mass is in gram, displacement or the length is in centimeter, and time is in second. So 1 gram centimeter per second square. 1 gram centimeter per second square is 1 dyne. 1 dyne is the CGS unit of force. Now we are relating, for example, we can relate the centimeter with meter. 100 centimeter is 1 meter, or 1 centimeter is 1 by 100 centimeter. The same way we are relating, since Newton and dyne are units of force, we can relate it. So 1 Newton is equal to 1 kilogram into 1 meter per second square. M is 1 kilogram, A is also 1 meter per second square. So 1 kilogram 1 meter per second square meaning 1 meter divided by 1 second square. So 1 kilogram into 1 meter divided by 1 second square. See, 1 kilogram is nothing but 1000 gram. 1 meter is nothing but 100 centimeter. And second, there is no change both in CGS unit and SA unit, MKS unit or the SA unit. The time, the unit of time is same, that is nothing but a second. So 1000 into 100, that is 1 lakh. So 1 lakh gram centimeter per second square. So 1 Newton force is 1 lakh gram centimeter per second square or 10 power 5. This is nothing but dyne. So 1 Newton force is 10 power 5 dyne. And similarly, 1 dyne is equal to 1 by 10 power 5 Newton. 1 dyne is equal to 1 by 10 power 5 Newton. So 1 by 10 power 5. 1 by a power m is equal to a power minus m. So we can relate it as 10 power 5, 10 power minus 5 Newton. 10 power minus 5 Newton. That is the 1 dyne force. 1 dyne force is equal to 10 power minus 5 Newton. Now we are looking at the gravitational unit of force. Gravitational unit of force. Gravitational unit of force is nothing but the force acting on a body of mass. The force acting on a body of mass 1 kilogram. Force acting on a body of mass 1 kilogram by Earth. Earth attracts every body towards the Earth's center. And if the body is having 1 kilogram mass, then what is the attraction or what is the force exerted by Earth on the body? The force exerted by Earth on the body of mass 1 kilogram. We are having 1 kilogram of mass of a body, or we can also call a body is having 1 kilogram mass. And in this particular body, what is the force exerted by the Earth? That is nothing but we will be calling as gravitational unit of force. So that is the unit is nothing but kilogram weight. What is the unit of gravitational force? The unit of gravitational force is kilogram weight, or we can also say kilogram force, kgf or kgwt. kgwt or kgf stands for gravitational force. So this is also unit of force. So again we can relate it with the Newton as well as with the CGS unit. In CGS unit the force is nothing but dyne. So we will be relating the gravitational unit of force with SA unit, that is Newton, and CGS unit, that is dyne. So we will be relating to both Newton as well as dyne. Before that we have to look what it is actually. So now we know that from Newton's second law, F is equal to ma, where m is the mass of the body and a is the acceleration produced in the body. So if you are considering any body which is falling towards Earth, it falls with the acceleration that is called acceleration due to gravity. That is because of the pull of the Earth, the falling body is accelerated with a magnitude 9.8 meter per second square. With a magnitude 9.8 meter per second square. So what is the acceleration? This particular acceleration we call it as g. G is equal to 9.8 meter per second square. You may have already learned while learning the kinematics. I hope so. Now we are understanding the force exerted on a body of mass 1 kilogram by Earth. The force exerted by Earth on a body of mass 1 kilogram. So force F is equal to ma. here we can, since it is here A is nothing but G, so we can write the force is mg. Okay, what is the force exerted by Earth on a body of mass m? That is mg. Force exerted by Earth on a body of mass m is mg. For example, if I am having mass m, then force exerted by the Earth on me is mg. If you are having a mass m, then force exerted by on you by Earth is mg. For example, if m is 50 and g is 9.8, then 50 into 9.8 is Newton. 50 into 9.8 Newton is the force exerted by Earth. What will be that? Now, on moving towards, we are considering m is equal to 1 kg and g is equal to 9.8 meter per second square. So 9.8 kilogram meter per second square or 9.8 Newton. So if a body is having 1 kilogram mass, then it is attracted by Earth. Then that particular body is being exerted. That particular body is being exerted with a force 9.8 Newton by Earth. Earth exerts the force on that body. The force exerted on the body is 9.8 Newton by Earth. So the magnitude is 9.8. So 1 kilogram weight, now we are connecting it. 1 kilogram force or 1 kilogram weight is equal to 9.8 Newton. So for example, if m is my mass, okay, then in order to get the force, I have to multiply with 9.8, right? In 9.8 Newton we can say. Instead of, we can just say m kilogram weight. What is the force exerted by on me? M kilogram weight. If you are having a mass of 45 kilogram, then the force exerted by on you in Newton is, you have to write it as 45 into 9.8 Newton. Instead of that, if you are using this method, what you can write? 45, you can just write 45 kg weight, 45 kg weight. So it is a simple method to write to express the force exerted on a body by Earth. If you are having mass 30 kilogram, you can just write 30 kg weight. If you are writing in Newton, what you have to do? You have to go for this way. 30 into 9.8 Newton. Instead of that, you can just write 30 kilogram weight is the force exerted by on you by Earth. Force exerted on you by Earth. So that is, in order to for the simplicity only, we are introducing the gravitational unit of force. Now we are relating it with the die, so that our discussion will be over. See, 1 kilogram weight is 9.8 Newton. We already learned it. And now we are understanding 1 kilogram weight, 1 gram weight. Gram weight is the unit of force, unit of gravitational force in CGS unit. In CGS method, what is a gravitational unit? Gram weight. In SI unit, what is a method, or what it is? Kilogram weight. In SI system, kilogram weight. In CGS system, it is gram weight or gram force. Here we can say gram weight, gram force, kilogram weight, kilogram force, or here we will be telling gram weight or gram force. So what is the force is? Whatever it is, force is equal to ma. So we are going from the base where m is the mass and a is the acceleration produced in it. When a body is falling vertically downward due to the pull of Earth, if you are neglecting the air resistance, then it will fall with the acceleration 9.8 meter per second square. It it will fall with an acceleration 9.8 meter per second square. So any body is accelerated with magnitude 9.8 meter per second square. Any body is accelerated with a magnitude 9.8 meter per second square because of the force of Earth, because of the gravity of Earth. Now, see, 9.8 meter per second square, we have to convert it first to centimeter per second square. This is actually in SI unit, or it can be also called as MKS. M is, that is length, this one is time. Length is in meter, time is in second. So MKS, the M stands for meter and S stands for second. Now 9.8 meter per second square is nothing but 9.8 into 100 centimeter. 1 meter is 100 cm. So 9.8 meter is 9.8 into 100 centimeter. So 9.8 into 100 centimeter per second square. Okay, in second there is no difference. So that is 980 centimeter per second square. So the acceleration due to gravity in SI system is 9.8 meter per second square, whereas in CGS system it is 980 centimeter per second square. The acceleration produced by a body, produced on a body by the force of Earth is 980 centimeter per second square. 980 centimeter per second square. That is expressed in CGS unit. Now we can look at it. See, what is the acceleration? 9.8 again 980 centimeter second square. 980 centimeter per second square. And mass we will be considering 1 gram mass. So the force exerted by Earth on mass of 1 gram. Here force exerted by Earth on 1 kilogram. Here force exerted by Earth on 1 gram. So 1 gram into MA. What is M? M is 1 gram. What is A? 980 centimeter per second square. So 1 into 980, nothing but 980 centimeter per second square, or we can also call 980 dyne. So gravitational unit of force in CGS system is 980 dyne, whereas gravitational unit of force in SI system is 9.8 Newton, or we can also call 9.8 kilogram meter per second square. Thank you.